Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. Today's topic is CD circuit and I shall be teaching you the various circuit rules for current, voltage and resistance. So let's begin. As you can see, this is a circuit diagram for a CD circuit. Shown in the diagram are the cell. This is the positive of the cell. This is the negative. The arrows indicate the direction of the conventional current. Also, as you can see, there is a voltmeter connected across the components. So as you can see over here, this voltmeter is connected across the cell, which is the source of the power supply. So this is basically the power supply, it's the source of current. So voltmeter is connected across the power supply. Even here in this case, the voltmeter is connected across first lamp. Here the voltmeter is connected across the second lamp. So as you can observe, voltmeter is always connected in parallel to any given component. Similarly, as you can see, A stands for ammeter. Over here again A stands for ammeter, and ammeter is always connected in series with the electrical components. It is never connected across the components. Okay, and let me tell you about the further labelings. I1, everywhere that you can see, this I1, in fact all the I1s stand for the current. Similarly, R1 stands for the resistance of the first lamp, R2 stands for the resistance of the second lamp, V stands for the EMF of the power supply, V1 stands for the voltage across the first lamp, V2 stands for the voltage across the second lamp. Okay, so now with this basic information, let us move ahead and learn about the various circuit rules. So this is the first circuit rule. The circuit rule tells you that the same current passes through components in series with each other. Now let's understand what that means. This means the same current passes through components in a series circuit. As you can observe, everywhere the current is labeled as I1. It is not labeled as I2, I3. So everywhere I1 means the same current is flowing. In other words, this means that suppose, I'm giving you hypothetical examples. So if suppose the current in the circuit at this point, at the first I1 from the positive terminal, suppose it is 3 amps. So that means the same 3 amps is going around everywhere in the circuit. So that means at this point it is 3 amps, again here it is 3 amps, here again it is 3 amps, and here again it is 3 amps. Also here it is 3 amps. So I1 is repeated all over. That means the same current is passing through a series circuit. So whatever circuit, so throughout the circuit, wherever there is a current shown in a series circuit, it will be having the same value. So this is the first rule: the same current passes through components in a series circuit with each other. Now going to the second rule for the series circuit, and that's about the resistance. The total resistance of 2 or more resistors in series is equal to the sum of their separate resistances. Now let's understand what this means. The total resistance of 2 or more resistors in series is equal to the sum of their separate resistances. Meaning over here, as you can see, I have shown you the lamps, because remember, even the lamp will have certain kind of resistance. The tungsten filament in the lamp will offer some resistance. So I have taken the value of the resistance of the lamp to be R1 and the resistance of the second lamp to be R2. So what it means is the total resistance, meaning if I take the combined resistances of lamp R1 and R2, it will be equal to the sum of their separate resistances. So for example, suppose if this lamp R1 has offered a resistance equal to 10 ohms, and suppose this lamp R2 has offered a resistance of say 5 ohms. So because it is a series circuit, what the rule says is the total resistance will be equal to R, and that is equal to R1 plus R2, that is equal to the sum of the individual resistances. So 10 plus 5 is 15 ohms. So this is what the second rule means. Now going ahead with the third rule. Well, the third rule is about the potential difference. The total potential difference across a power supply in a series circuit is shared between the components. So that means the total potential difference, that is V. So V will be equal to, so if I take this as V, this V over here will be equal to V1 plus V2. That is the voltage across the power source will be equal to voltage across the first lamp plus voltage across the second lamp. So that will be equal to V1 plus V2. So whatever is the voltage of the first lamp plus the voltage of the second lamp will give you the voltage of the power supply, and voltage of the power supply is nothing but the EMF. So EMF of the cell is equal to the sum of the voltages of the individual components in a series circuit. So here I'm not giving you the values of V1, V2 because I still haven't taught you the Ohm's law. So I will not be using the Ohm's law to calculate the voltage across the individual lamps and the EMF of the cell. So as of now, I would only like to tell you that V is equal to V1 plus V2, meaning V, which is the EMF of the cell, is equal to the sum of the individual potential differences across the lamp 1 and lamp 2. So let me just write down statements supporting these rules. So for the first statement for the current, there is no statement as such basically, because it's like the same current passes through the components. If at all, I would have labeled this as I2, this as I3, and this as I4, this as I5, and this as I6. Then I could have made a statement, and the statement would have been I1 is equal to I2, which is equal to I3, which is equal to I4, which is equal to I5, and which is equal to I6. Okay, that would have been a statement. Now for the next one, the total resistance of the two resistors. So if I want to take the total resistance as R, the statement would have been R equals R1 plus R2, and for the potential difference it would have been the total EMF of the cell, which can be written as V. So V equals V1 plus V2. So these are the three circuit rules for a series circuit: the rules for current, the rule for resistance, and the rule for potential difference. So that's all in this video on series circuit. I hope you like watching my video. Please do subscribe to my channel if you like. Okay, now that's all. What I meant is not in the entire video. That's all about the rules for the series circuit. Now, if you remember, I have told you in the beginning of this video that I shall be solving a question which is taken from IGCSE past paper, and so we shall just solve one of the questions. And I've chosen the question because the question is a bit tricky. Okay, so with that, just move ahead. Okay, so this is the question. Now this question is exactly the same question that is appearing in May June 2012 paper 3-2 and question number 9. So I have just rewritten this in ink so that I can solve it and I can explain to you in a better way. So the question says 40 lamps, each of resistance 8 ohms, are connected in series. So it's like there's a power supply, and across the power supply, because it is in series, so you will have lamp 1, lamp 2, lamp 3. In that way there are 40 lamps in series. That's what they have said. And 40 lamps are in series, and resistance of each lamp is, so each lamp's resistance is 8 ohms. They are connected in series to a power supply of 240 volts. So there is a power supply of 240 volts, and in series with the 240 volts there are lamps attached. There are 40 lamps, and each lamp has a resistance of 8 ohms. And we have been asked to calculate the current in each lamp. Now, before we do that, okay, we'll have to make use of Ohm's law. I shall teach you the Ohm's law in my next video, but I'll tell you how to solve this. Now, for example, suppose we know that Ohm's law is V equals IR, that is voltage equals current into resistance. So we are supposed to find the current in each lamp. So that means we are supposed to find the value of I. I is V upon R. We know that voltage is 240 volts. We need to find the total resistance in the circuit. Now, as I have said earlier, that every lamp has a resistance of 8 ohms. So if one lamp has a resistance of 8 ohms, therefore we have how many lamps? 40 lamps. So if I find the resistance of 40 lamps, it will straight away mean that is equal to 40 into 8, and which is equal to 320 ohms. That means here the total resistance will be 320 ohms. So I'm writing this in different color. So 320 ohms. Now when I divide this 240 by 320, I get 6 upon 8, which I further calculate. It gives me 0.75 amperes. That means the current, when the current in the circuit that is passing through each lamp is 0.75. So let me just label this. So the current is equal to 0.75 amps. So this is 0.75 amps. So we have calculated the current in each lamp. And why am I saying is in each lamp? Just now I explained to you the current in the series circuit is same. So if 0.75 is passing from here, the same 0.75 goes from here. The same current enters this lamp. Similarly, even the 40th lamp is going to get the current which is equal to 0.75 amps. What comes out of the 40th lamp is also 0.75 amps. This is what I mean when I say the current is same in the entire circuit. Okay, now we have answered this part of the question. Now let's move ahead. Now here be careful, this is a very big question. The best is if you have a copy of May June 2012 paper 3-2 question number 9, you can just refer to it. If not, then you can pause the video, you can copy the question so that you have the data in place, and then you can start solving. Okay, so now let's begin. The question says the lamps are designed to fail short. If a filament fails, the lamp shorts so that it has no resistance. The other lamps continue to light and the current increases. The lamps are connected through a fuse that blows when the current rises above 0.9 amps. At this current, the resistance of each lamp is 5% greater than its normal working resistance. So calculate the maximum number of lamps that can fail before the fuse blows. Now, as they have told you that the lamps are connected through a fuse that blows when the current rises above 0.9 amps. That is 0.9 amps is the maximum current that can pass through the circuit without blowing the fuse. So when the current is 0.9 amps, at this current the resistance of each lamp is 5% greater than its normal working resistance. So that means the normal working resistance in this circuit was 8 ohms. We have seen it is equal to 8 ohms. Okay, they've already given you over here that 40 lamps each of resistance 8 ohms are connected, meaning normal resistance was 8 ohms. And they are telling you when the current exceeds 0.9 amps, then the fuse blows, and at that current the resistance is 5% greater than its normal resistance. So let us calculate the resistance. So resistance of each lamp is equal to, how much was it more? 5% greater than the normal. Normal was 8 ohms. 5% means 5 upon 100 and 5% of 8. So this leaves us with 8.4 ohms. Also we know that the battery voltage is not changing, so it is going to remain 240 volts. Okay, now maximum current that can flow through the circuit has been given as, so maximum current they have given you as 0.9 amps. So this is 0.9 amps. Okay, so now we have the maximum current, we know the battery voltage, so we can find out the maximum resistance of the circuit when the current is 0.9 amps. So that means again we'll apply Ohm's law. So when we apply Ohm's law, we know V equals IR. So we also know that maximum current is equal to 0.9 amps. Now this is equal to V upon R. That means the current in the circuit is equal to the total battery voltage, that is 240 divided by R. And further calculation gives us that R equals 266.67 ohms. 266.67 ohms. Okay. Also, when the fuse blows, if each lamp has resistance equal to 8.4 ohms, therefore we may say that X lamps have a resistance, meaning a total resistance of, we just now found, 266.67 ohms. Therefore X is the number of lamps that have a resistance equal to 267. So X is equal to 266.67 divided by 8.4 ohms, and that leaves you with 32 lamps approximately. That means they have asked you calculate the maximum number of lamps that can fail before the fuse blows. So the maximum number of lamps that fail before the fuse blows is 32. 32 lamps. The answer is 31 point something, but rounding off gives you 32. So this is the maximum number of lamps that fail before the fuse blows. Okay. So that's all in this video. I hope you like watching my video. Please subscribe to my channel to keep yourself updated. Thank you so much.